Our last feature that we're going to concentrate on when graphing rational functions are horizontal asymptotes. So if you look at these two pictures, you can see that we can almost draw an invisible line right here, and you can actually see the dotted one here. And again, these are lines that our graphs approach. The big difference between horizontal asymptotes and vertical asymptotes is that the graphs can touch. Okay, they're allowed to touch. You can see that it's touching here. In some cases, you might see, if I draw a little one right here, if a graph could look like this, you'll see this in pre-calc, where it oscillates, and there's a horizontal asymptote. But in either way, you see your graph approaching this value. So when they occur when the function approaches a certain value as x goes to infinity and negative infinity. And how do we find them? It's all about looking at the degrees of the numerator and the denominator. Alright, so you need to remember what a degree is. So here are a couple of examples, a review of what a degree is. Now remember, a degree is the highest exponent in your polynomial function. So f of x, our highest exponent, is 5. So this would be a degree 5 polynomial. G of x, notice that it is also a degree 5 polynomial. Although it's not in standard form, a lot of students want to say that it should be a degree 3 polynomial, but it has nothing to do with what order it's listed in. It's all about what the highest degree is, or the highest exponent is. So we have three cases. We have top heavy, meaning the higher degree is in the numerator. We have bottom heavy, where the higher degree is in the denominator, and we have the same, so it would be have the same degree on top and the same degree on bottom. Now depending on which of these three cases are given, your horizontal asymptote could differ. So in this case, we have top heavy. We have a degree 7 in our numerator and a degree 4 in our denominator. So you can see that it is top heavy. When it is top heavy, we have no horizontal asymptote. There aren't any. As you see in this graph, it does not approach a value. As x goes to positive infinity, our graph is going up towards positive infinity. And as x goes to negative infinity, our graph, is going down towards negative infinity. So there are no horizontal asymptotes if it is top heavy. Now if it's bottom heavy, in this example we see that we have a degree 2 on top and a degree 3 on bottom. So it is bottom heavy. When we have a bottom heavy rational function, we do have a horizontal asymptote. In this case, our horizontal asymptote is going to be at y equals 0. And we're going to play this video to show you sort of why that is the case. So I plugged this function into my calculator, as you see, making sure that I put my numerator and denominator in parentheses. Now what ends up happening as you start to plug larger and larger and larger numbers into this function, whether it's negative or positive, you can see as I get larger and larger negative, my y values are getting closer and closer to 0. And as I plug larger and larger values to my that are positive, again, my y values are getting closer and closer to 0. Here's Desmos, where you can see that as I keep going towards positive infinity, my graph is getting closer and closer and closer to 0. I'll back up and you can see that even as I get larger and larger and larger, my function approaches 0. It never actually touches 0 in this case, but it does get close to 0. And the reason behind that is if I plug in a huge number, say if I were to plug in 1 million into this function, taking 1 million and cubing it is going to make that denominator huge. And even though the numerator will be large as well, the denominator is going to be so massive that when I take whatever this numerator is and divide it by this massive denominator, it's going to get closer and closer to 0. Here's another example where it is bottom heavy, but as you can see, we have a constant being added. So what ends up happening here is this part of my function goes to 0. But the fact that I'm shifting this up 3 by adding 3, as you can see in my graph, I do have a horizontal asymptote at 3. So when it's bottom heavy, your horizontal asymptote is always going to be whatever is being added or subtracted. Now in the last example, we weren't adding or subtracting. We were adding or subtracting 0, if you will. And that's why our horizontal asymptote was at 0. In this case, our fraction itself will go to 0. Again, take 1 million, plug this in, you end up having 4 divided by a huge number, which is going to be close to 0, and then we're going to add 3 to it. And that's why we have a horizontal asymptote at 3. Now if we have the same degree on top and bottom, so we have a degree 2 on top, we have a degree 2 on bottom, what we're going to have to do is look at our leading coefficients. So in this case, we have a leading coefficient in our numerator of 4. And we have a leading coefficient of our denominator of 8. So we have 4 over 8, which is 1/2. And that will be our horizontal asymptote. If you take a look at this graph, here's 1, 1/2 is right here, and you can see that our graph is approaching this horizontal asymptote of 1/2. Now in this second example, you can see again we're adding a constant. So in this case, we do have a degree 2 on top, again degree 2, and a degree 2 on bottom. So we'll take the leading coefficients, which are 5 and 1, so that's 5. And because we are shifting this down 2, if we take our leading coefficients of 5 and shift it down 2, we end up getting a horizontal asymptote of 3. And it's tough to see here. Each one of these markers are 2, so that's 2, that's 4. So, but if we go halfway between, that's 3. And again, we can see that our horizontal asymptote should be at 3, and that's where our graphs sort of ride along that. Now a lot of that can be daunting to take in all at once. So this might be a really good thing to put into your notes if you're still keeping a notebook during this. You can see that when it's top heavy, meaning that degree is higher on top than on bottom, we have no horizontal asymptote. If it is bottom heavy, meaning our higher degree is in our denominator, our horizontal asymptote, it's just going to be whatever this is. So if this was plus 3, our horizontal asymptote would be plus 3. If we were subtracting 5, our horizontal asymptote would be y equals minus 5. This should be y equals positive 3. Okay? And then if it's the same, then we take our leading coefficients and we simplify that if we can, and then we would add or subtract whatever our constant being added is.